First question says, using the steam tables, determine this specific enthalpy per kilogram of steam if the pressure is 100 and then if the steam is dry saturated and if the steam is 0.9 dry. So the first thing that we need to do now is to write something in bracket here to say that dry saturated, it means the question says we need to calculate HG. The first question. The second one, we have to calculate HVAC. We have to calculate HVAC. So the first one is HG. HG is what? The specific enthalpy of dry steam. So the steam is dry and the steam is 90% dry, which is HVAC, while the pressure is 1,400. So again, I'm going to use two methods that we used before. So the first one is going to be HS diagram. Let's go to HS diagram. We determine HG at 1400. 1400. Okay. Where is the Mollier diagram? The pressure is 1400. Let me just delete this, erase. Okay. The first thing now that we need to do is to locate a 1400 pressure line. So this is 1 megapascal, 1.2, 1.4. So here is 1.4. 1.4 pressure line, right? And then we are told that the steam is dry saturated, which means that the intersection of the pressure line and this line here is where we are. And then you take a ruler, you draw a line from that intersection to your right, sorry, to your left. So according to what I have here from the Mollier diagram, it is 2790 kilojoules per kilogram. And then we can go back and then we say, according to the Mollier diagram, the answer that I got here is 2790 kilojoules per kilogram. That is the first one. Let's do the second one again using the Mollier diagram. The pressure is 1400, the steam is 0.9 dry. We determine enthalpy from the Mollier diagram. The pressure is 1400. Here is your pressure line, 1400. And then where is your 0.9? Here is a 0.9 dryness fraction line. You follow that line. The intersection takes place exactly at 2600. So the H word is 2600. And then we go back and then we write it down that the H word is 2600 kilojoules per kilogram. Now let's move on to the tables. Now we want exact answers now, not approximate answers. Now we are going to the steam tables. At 1400, we determine HG. Let's go to the tables. Here is the table. Because the steam is dry saturated, we use pressure table. Pressure table, this is the pressure table, yes. 1400. Where is 1400? Here is 1400. So HG corresponding to 1400 is what we are looking for. So HG here is 2788.9. 2788.9 kilojoules per kilogram. Can you see how close we are? Mollier diagram says it's 2790. We get 2788. So we are almost there. Let's have the second one. The second one, we have to calculate H word. H word, we know is what? It's HF plus X HFG at 1400 kPa. So now we go to the steam tables. we get HF and HFG at 1400. Let's do it. At 1400, HF is 829.96. 829.96 plus X is given 0.9. 0.9 multiplied by HFG at 1400 is 1958.9. 1958.9. And then we calculate. Where is my calculator? So it's 0.9 multiplied by 1958.9 plus 829.96, 2592. 2592,97 kilojoules per kilogram. Can you see how close we are? The difference here is what? It's only 8. So 92 and 100, so it's almost there. So we are very close. So these are the two methods that you can use to double check your answers. The question did not say use a Mollier diagram. I'm the one who decided to bring a Mollier diagram so that at least you understand how to use a Mollier diagram. So it simply said calculate HG and wet steam at 1400, and that's it. So the correct answer is 28, 2788, and 2592. So we are done with the first one. The second one. The second question. For now, that is not necessary, and 3 is not necessary. And then question 4 is your homework. I am going to do question 5. I'm going to do question 5. And I would like you to listen very, very carefully. Question 5, there's a mistake there. The question says you calculate the energy to change the energy to form wet steam with a degree of 0.9. Sorry, 9.0. It's actually 0.9, not 9.0. So the Reynolds fraction, that is 0.9, not 9.0. That is a mistake. It's a typing error there. So let me copy this so that I can solve it for you. Okay, copy. Right. So I'm going to paste. Okay. Increase the font. Right, let's start. The first question says that from a water supply of 7 degrees Celsius, the pressure is 1.1. Now you determine the change in enthalpy per kilogram of steam required to form the wet steam. First of all, you need to understand the question. Let me change this. It is not 9.0, it's 0.9. 0.9. So basically what is happening here is that you have water at 7 degrees Celsius. Here is your water at 7 degrees Celsius. Guys, I'm experiencing problems again. I don't know what is happening in this machine. I just don't know what is happening here. Okay, now this thing is refusing to write. It's refusing to write. Oh, ladies and gentlemen, problems again. Problems. My pen is not writing. I wanted to throw a sketch here to explain what is it that needs to be done. But unfortunately, seems like we are going to have the same problem again. Every year, every session, we have the same problem. Oh yeah, it looks like we. Okay, yeah, we are good. We are good. We are good. Okay, so let's start. Yeah, let me change to black. Right. So this is what we have. We have water at 7 degrees Celsius. That is the temperature of water. And the pressure of this water is 1.1 megapascal. And then here we have a wet steam. Wet steam, the pressure, remember, is still the same. And then dryness fraction here is 0.9. So the question says calculate the energy that is required, delta H, the energy that is required to change water from 7 degrees Celsius to make it wet steam of 0.9. Calculate or determine the energy that is required to change or to transform water from 7 degrees Celsius to make it 90% vapor. So all we need to do now is say that, okay, we will say that delta H, change the energy that is required, is going to be enthalpy of wet steam. This minus this, we will get the difference is what we are looking for. So it's going to be H wet minus enthalpy, HF, at 7 degrees Celsius. That's what we are looking for. Now let's move on to the second one. I'll come back to that question in case we have problems with my system again. At least I've explained. This is A. B. Now here we don't have wet steam. Now we have HG, dry saturated steam. So the question says, calculate the amount of heat required to transform water from 7 degrees Celsius to the dry steam. So the difference between dry steam and water at 7 degrees Celsius is what we are looking for. So we say delta H again is going to be Hg minus HF at 7 degrees Celsius. That's what we are looking for. The last one. Now here we don't have Hg, now we have steam, superheated steam. The temperature of that steam is 205. Now the question says, calculate the amount of heat required to transform that water from 7 degrees Celsius to 205 degrees Celsius superheated steam. Again, we still say that delta H is going to be H sub minus HF at 7 degrees Celsius. Let's start with HF at 7 degrees Celsius. There are two methods that we can use to calculate HF at any temperature. So HF at 7 degrees Celsius is equal to what? You can go to the table, but sometimes 7 does not appear on the table. You have to interpolate. So interpolation is the waste of time sometimes. Let's go back to the tables and check if 7 degrees Celsius appears on the table. We go to the steam tables, and then we go to pressure table and temperature table. Can you see under pressure table, there is no 7. It is only 6.97. Let's go to temperature table. Temperature table, there is no 7. It's 5 and 10. So for you to get HF in between here, between 21 and 42. Can you see now the HF is going to be between 21 and 42? You have to interpolate. This is a very easy thing to interpolate. It's a waste of time. So we are going to use a different formula. Now, if we use the pressure, I know some people do cut corners. They will say, okay, in any case, 6.97 is very close to 7. They will say, I'm going to take HF, which is 29.303. When the temperature is not 7, but when it's 6.97, 29.303. Let's use the second method. The second method, we can say that it's going to be Cp for water multiplied by temperature to get HF. So HF is equal to Cp multiplied by temperature. Cp is only for water, because at 7 degrees Celsius, we still have water, not steam. So Cp for water is 4.187 multiplied by temperature, which is 7 degrees Celsius. We multiply the two, 4.187 multiplied by 7, 29.309. 29.309 kilojoules per kilogram. Let's go back and check from the tables. Here is 29.303, so they are almost the same. So you can see that there are two methods in which you can determine the temperature or anything that you want. You can either take that one or you multiply by a Cp, which is 4.187 by 7. Now listen to this. You can only multiply by this value, 4.187, to temperatures up to 100 degrees Celsius. Anything over 100, you don't apply this because you have a mixture of water and vapor. It's no longer water. You only use when you have water. At 50, you still have water. At 90, you still have water. But at 120, is vapor plus water. You cannot use 4.187. You have to use the tables. So to save time, if you use 4.87, you are still going to get the same answer as use the tables. So HF here, we already have it. Here we have 29.309. All we need to do now is to calculate the HF. HF or H wet. H wet is equal to HF plus X HFG at 1.1 megapascal. So ladies and gentlemen, we have to go back to the tables to determine HF at 1.1. 1.1, remember we are dealing with wet steam, eh? So we still use these tables, not the superheated. 1.1. 1.1, here is 1.1 megapascal. Now we are looking for HF. HF is 781.03. 781.03 plus X 0.9. 0.9 multiplied by HFG 1999.6. 1999.6. I'm not going to give you the answer. You can always calculate it. There's no time for that. Now HG 1100. At 1100, HG is 2780. 2780. Sorry. 2780. Kilojoules per kilogram. So what you need to do, you take this, you deduct that, you'll get the answer. The last one is the H soup. H soup, the fact that it's H soup, we are given Cp. We don't use the first method. So Cp, H soup says H soup is equal to Hg plus Cp T soup minus Ts. So we go to the steam tables. Hg It's already 2780. We have it. 2780. Ladies and gentlemen, you only use this particular formula here if CP is given. If it's not given, you don't use this method. CP in this case is given, and this CP, because it's superheated steam, it is not the same as that one. You see, this CP for water is not the same as that one. So you cannot use this CP here for a soup. You can only use this formula if CP is given. If it's not given, I will show you which method to use. So CP is given as what? Let's go up 2.1. 2.1 bracket T soup is 205. Is given 205. TS is saturation temperature. Saturation temperature at 1.1. You go to the steam tables. Saturation temperature at 1.1 is 184.06. It is here. This is T saturation. 184.06. 184.06. So you will get the answer. The answer that you get, you put it here, you deduct that one, you will get the same